This is the solution to problem number 3 from homework 3.3. So in the first part, we're asked to use a graphing utility, that means your calculator, and to graph the two equations. Use the graphs to verify that the expressions are equivalent. So the two expressions are y1, which I graphed here as f1 of x, which was x to the fifth minus 3x cubed over the quantity x squared plus 1, and y2, which is here, which I graphed as f2 of x, which is x cubed minus 4x plus 4x over the quantity x squared plus 1. And if you look at the graph, you'll see that f1 of x and f2 of x over, they are exactly the same. They're the same functions, right? Because we can only see one of the two. So now we're going to see that these two expressions are actually equal by verifying that with long division. So let's go ahead and do the long division. So to do this long division, we have to recognize that there are a number of missing terms. So we are actually going to be dividing x to the fifth. Let's go ahead and set up the long division, recognizing that there are quite a few missing terms here. So we're actually going to have x to the fifth plus 0x to the fourth minus 3x cubed plus 0x squared plus 0x plus 0 is the dividend, and the divisor is x squared plus 1. I usually don't put in the missing terms in the divisor, but you are welcome to put a plus 0x if that helps you with the long division. So let's set up the long division. Inside the little house, I'm going to put the dividend, which is going to be x to the fifth plus 0x to the fourth minus 3x cubed plus 0x squared plus 0x plus 0. And then outside the little house, we are going to put the divisor, which is x squared plus 1. When we're beginning long division, we look at the highest power terms. So we're going to say, how many times does x squared go into x to the fifth? Or what do you multiply x squared by to get x to the fifth? That is x cubed. And I'm going to write that over the x cubed term in the dividend. And now we're going to multiply x cubed by each term in the divisor. So x cubed times x squared is x to the fifth. I'm going to write that beneath the x to the fifth term. And x cubed times 1 is 1x cubed. I'm going to write that beneath the cubic term. And now we need to subtract. So we have x to the fifth minus x to the fifth, which is 0x to the fifth. I'm not going to write that. 0x to the fourth minus nothing is still 0x to the fourth. Negative 3x cubed minus 1x cubed is negative 4x cubed. And I'm going to bring down the plus 0x squared, bringing down the next term. All right, now we're going to begin the process again, and we're going to say, how many times does x squared go into 0x to the fourth? That would be 0, so we can skip that. So let's say, how many times does x squared go into negative 4x cubed? And that would be negative 4x times. So I'm going to write that over the linear term. And now we're going to multiply each term in the divisor by the new term in the quotient, which is negative 4x. So we're going to have negative 4x times x squared is negative 4x cubed, and negative 4x times 1 is minus 4x. And you'll notice that we skipped that x squared term, so I better go back and bring down the 0x. Bring down one more term. And that's happening because we're missing the 0x term in the divisor. All right, now we're going to go ahead and subtract. So negative 4x cubed minus negative 4x cubed is 0x cubed. So I'm not going to write anything there. 0x squared minus 0x squared is 0x squared. I don't think we need to write that because that's going to be the leading term here. And 0 minus negative 4x is like 0 plus 4x, which is 4x. And then we can bring down another 0. Then we're going to ask, how many times does x squared go into 4x? It doesn't. So actually 4x, we don't need the plus 0. That's our remainder. So we're going to add that on, so to our quotient, and we're going to add that on as 4x over x squared plus 1. So what we've shown, in effect, is that what we started with, which was x x to the fifth minus 3x cubed over x squared plus 1 is equal to x cubed minus 4x plus 4x over x squared plus 1. And these are the original functions that we were working with. We showed that x to the fifth minus 3x squared over x squared plus 1, that was our f1 of x, is equal to x cubed minus 4x plus the quantity 4x over x squared plus 2. That is our f2 of x. So we have verified that these two functions are equivalent by long division.